Now we want to use this fact just to show that R of D is the best possible rate distortion function. Therefore, we do the same like we do before. We know that x hat of n and xn. So we know that the codebook has 2 to the nr sequences x hat of n, and x hat of n is a function of xn. Because of this reason, we have n times r is greater equal the entropy of x to the n, and this is greater equal than the entropy of x hat to the n, because it's a function of this. That's like before we have in the proof in the source coding proof before. Now we can add, because again, x hat of n is a function of xn. You know that the entropy of this entropy is 0, so we just can write this in this way. But then we get the mutual information. This mutual information we can also write in this way here. So we have the mutual information of xn minus the mutual information of xn conditional on x hat of n. And this we can write as this sum here. This somehow like it's defined, or it's a usual formula. So we can write this by this individual random variables. We can write it as a sum from I equal 1 to n h of xi minus h of xi conditional on x hat of n and xi minus 1. Now we remove, so we replace this condition by this condition here. And of course this is less, so this here is bigger than this, but it's a minus in front, so this total sum is smaller than this sum here. So this is lesser equal than the sum from I equal 1 to n, the entropy of xi minus the entropy of xi conditional on x hat of I. But this is exactly the mutual information of xi and xi hat. So we sum over the mutual information from I equal 1 to n of xi and xi hat. Now we know that this is of course greater equal than the rate function of the expected value of dxi and dxi hat. Because we know from our formula that this minimizes the mutual information for this distortion. So what we have, we know that the rate is greater equal than this sum here. That's what we have from the previous page, just by inserting this for the mutual information here. But now we know that our rate function is convex, which we proved before. So we can write this in this way. We can put the rate outside and get this here. If you look at this expression inside the brackets, this is just the expected value of dxn and x hat of n. But this we know, because of our formula, is greater equal than d, because the rate of d is non-increasing in d. So in totally we have that the rate is always greater equal than the rate of d. And so we have a real converse, because we know it's not possible to be better than our function r of d, for which we prove that we can achieve this. What did we prove? So let's do it in a little bit different way. We write here a little I and mean this function here. If we define Ri of d, before we call it r of d directly, as this formula here, then we prove that the rate function for a discrete memberless source with bounded distortion function d is equal to the associated information rate distortion function. So the rate of d is equal to this formula. And this is best possible. That's what we showed.